This week, SpaceX finally revealed detailed plans for America's next moonlander, the Starship HLS. For years, people had heard about HLS as the vehicle intended to return astronauts to the moon during Artemis III, currently targeted for 2028. But until now, very little had been shown publicly about what the spacecraft would actually look like or how it would operate. The newly released images and renderings now provide the clearest picture yet of the massive lunar vehicle SpaceX is developing. Starship HLS, short for Human Landing System, is designed specifically to transport astronauts from lunar orbit down to the moon's surface and back again. Unlike Apollo-era landers, this spacecraft is enormous. Standing nearly 52 meters tall, around 170 feet, the vehicle is closer in scale to a skyscraper than a traditional lunar module. According to SpaceX, it will contain approximately 600 cubic meters of habitable volume, an amount of interior space comparable to two International Space Stations combined, or roughly the inside volume of a Boeing 747. For astronauts accustomed to cramped spacecraft, the difference would feel extraordinary. One of the most striking elements revealed was the airlock system. HLS includes two large airlocks, each significantly bigger than the Apollo lunar module's single compartment. Real photos released by NASA and SpaceX show spacious staging areas where astronauts can suit up, remove lunar dust from their gear, and prepare for surface excursions. The airlock essentially functions like a garage or preparation chamber for moon operations. Because the spacecraft is so tall, astronauts cannot simply step down onto the lunar surface. Instead, they must use a large elevator system that carries them from the habitat section at the top of the vehicle down to the moon below. Early renderings show this elevator also being used to lower cargo and lunar rovers onto the surface. Once the mission is complete, HLS would launch back off the moon and rendezvous either with NASA's Orion spacecraft or the future Gateway station orbiting the moon. Another major reveal involved cargo capability. SpaceX stated that Starship HLS could potentially deliver up to 100 metric tons of equipment and supplies to the lunar surface in a single mission. That figure is dramatically beyond anything achieved during Apollo and would theoretically allow large rovers, habitats, scientific laboratories, heavy construction systems, or expanded astronaut crews to be transported directly to the moon. However, there is an important limitation many people misunderstand. HLS is not a complete Earth-to-moon transportation system. It functions only as a lander. Astronauts would still rely on NASA's Space Launch System and Orion spacecraft to travel from Earth to lunar orbit. HLS would meet them there, carry them down to the surface, and then return them to orbit afterward. Fueling the vehicle is where the architecture becomes especially ambitious. Starship HLS cannot launch from Earth with enough fuel to complete its mission. Instead, SpaceX plans to refuel it in low Earth orbit using multiple tanker spacecraft and orbital fuel depots. The process involves launching tanker starships repeatedly to fill orbital depots with supercooled propellant. Once enough fuel is accumulated, HLS would dock with the depot and transfer the required fuel before heading toward the moon. This approach introduces one of the biggest technical concerns surrounding the project. Large-scale orbital refueling has never been successfully demonstrated for a crewed lunar mission. Transferring cryogenic propellants in microgravity is extremely difficult because liquids float freely, bubbles form unpredictably, and maintaining fuel at ultra-cold temperatures for extended periods is a major engineering challenge. Estimates from analysts suggest the moon mission could require anywhere from a dozen to potentially 40 tanker launches just to fuel one HLS mission. The scale of the vehicle itself also raises concerns. Landing on the moon is already difficult because there is no atmosphere to help slow descent, gravity is weak, and terrain can be uneven. HLS adds another layer of complexity because of its immense height and mass. A tall spacecraft has a higher center of gravity, making stability during landing far more challenging. Many previous lunar landers were intentionally short and wide to reduce the risk of tipping over. If a spacecraft as massive as HLS were ever to fall sideways on the moon, the consequences for astronauts would likely be catastrophic. The narrator also questions whether such a massive spacecraft is truly necessary for the early Artemis missions. Initial lunar missions are expected to carry only 4 astronauts, yet Starship HLS appears designed for much larger ambitions. Interior renderings reveal huge open spaces that currently appear mostly empty. The suspicion is that the design may be driven less by near-term lunar requirements and more by Elon Musk's long-term goal of eventually using Starship for Mars colonization. In that sense, Artemis may also serve as a large-scale testing platform for future Mars systems. The elevator system itself introduces another concern. Because the crew compartment sits high above the lunar surface, astronauts are entirely dependent on the elevator for access. If the mechanism jammed or failed, emergency alternatives could become extremely difficult while wearing bulky spacesuits in lunar gravity. Compared to simpler landers like Apollo's lunar module, or even Blue Origin's Blue Moon concept, Starship HLS introduces many additional mechanical systems and possible failure points. Despite these concerns, NASA continues moving forward with the Artemis program. Artemis II is expected to send astronauts around the moon, while Artemis III is intended to return humans to the lunar surface for the first time since Apollo. Most of NASA's hardware, including Orion, the SLS rocket, and Gateway Station components, is already progressing toward readiness. The major uncertainty now centers around whether SpaceX can complete and validate HLS in time. Because of that uncertainty, NASA has also encouraged alternative commercial providers to accelerate backup lunar lander options. Blue Origin has responded by advancing development of its Blue Moon lander, which is considered technically less ambitious than Starship HLS, but potentially easier to operationalize in the near term. NASA's contract structure also protects taxpayers to some extent, because the HLS agreement is fixed price, meaning SpaceX bears the financial burden of delays and failed testing rather than NASA. In the end, Starship HLS represents one of the boldest and most ambitious spacecraft concepts ever attempted. If SpaceX succeeds, it could revolutionize lunar exploration and create capabilities far beyond anything achieved during Apollo. But the engineering challenges remain immense, and many experts believe the timeline may be far more difficult than current projections suggest.